Hi guys, I welcome you all to another class of math. Today I'm going to walk you through the journey of product tool in the calculus. So what do you mean by the word product tool in calculus? So product tool in calculus is just by when we have two different functions combined together with operation multiplication. So in that scenario, so we apply product tool in calculus. So let's see by example. Suppose we are given y equals uv. So y equals to uv is a typical example of product rule, where this u and v are the function of x. We are differentiating with respect to x, but initially we are given u and v. That the u and v are the function of x, not the function of y. So which means to obtain the product rule, which means we are going to differentiate this u with respect to x, then we differentiate v with respect to x. By doing so, we are going to obtain something like this, that the y divided by the x. Remember, we are differentiating with respect to x, not u and v. Then we are going to have, we keep this u, we are going to differentiate this v. When we differentiate v, we have the v divided by the x. Then plus product change to multiplication. Then we keep this v as well. Then we differentiate u. Here we have the u divided by the x. Okay, another way of writing this, another dimension of writing this product rule formula. So this is the product rule formula. So we can have this as y can still be y prime equals, so we keep this u, we differentiate v. But since I choose y here as the y prime, which means v here will still be v prime, plus then we keep v, we differentiate u. That is u prime. So this one is where we are giving the product of two different functions. Okay, suppose we are giving the product of three different functions. How are we going to do that? So let's say we are giving u, v, and w as the product of three different functions. To do that is very simple. So what we are going to do is, we keep 2 first, we differentiate 1. So we keep 2, we differentiate 1. Then by doing so, we are going to have the y divided by the x equals, so let's keep these 2 and differentiate this. We keep u and v, then we differentiate w, then we have the w divided by the x. Remember, we are differentiating with respect to x, not u and v. Then plus, so we have kept this before, we differentiate this. So we are still going to keep this and this, we differentiate this. So we keep u and w, we differentiate the v, then the v divided by the x. Plus the last one, which is this, we are going to keep this and this, then we differentiate this. So we keep v and the w, then we differentiate the u divided by the x. So this is where we are giving the product of three different functions. So as far as we know all this formula, we are good to go in any question in differentiation, in product rule differentiation rather. Okay, let's see the beauty of this in an example. Remember, if you want to apply product rule, the function we are going to be deriving will be different. So it can be of linear and exponential. Let's say exponential and trigonometry and logarithmic and others like that. If it can be quadratic and hyperbolic function and so on like that. As far as we have a kind of question like that, we apply product rule. So let's see the first example. Let's keep this question, this formula in mind. So the first example I'm going to consider here is, suppose you are given the product of the quadratic. Let's see example 1. Find the y, the x. If you are given y equals to x raised to the power of 2 sine x. So you know this one is quadratic and this one is trigonometry. So then we are going to let this one to be u. We let u equals to x squared. Any of these two can be u. You can let this one, you can let this one, but I'm letting x squared. So let's say v as well. We have v to be equals to sine of x. So to do that, we differentiate this. When we differentiate this, we are going to have this as u prime is still mean the u divided by the x equals to, this is 2x, right? And then v is phi prime. So the derivative of sine x equals to cos of x. So we have our u, we have our u prime, we have our phi prime. So to obtain the dy dx, which is dy divided by the x of product rule equals to, we keep this, which is u, then the phi divided by the x with the formula. Then we keep the second one, v, we are going to have the u divided by the x. And I've provided the ingredients that we need, so which is the parameters that we need. Then here is our u, we write u, then derivative of v, which is this, we place it, plus we have our v as well, which is sine x. Then the derivative of u, that is 2x multiplied by 2x. So here we are going to have this as x squared cos x plus multiplying this, we have this as 2x sine x. So you can leave the answer like this, or if you like, you can factorize. We have x here, we have x here, which is common. Taking out one x, we are going to have this as x cos x plus 2 sine of x. So this is the derivative of this particular product of two different functions, quadratic and the sine. Okay, if this is clear, let's see another example. So suppose we are given the product rule of the exponential and the polynomial function. Yeah. So let's see example 2. Suppose we have y equals to x raised to the power of 3 exponential of 2x. So to do this, still the same thing. Okay, I'm letting this one to be u now, so I will take this one to be phi. If this is u equals to exponential 2x and v equals to x raised to the power of 3. Okay, we differentiate this, which is the u divided by the x equals to, we take this thing back, so 2 exponential 2x, then the phi divided by the x equals to 3x squared. Okay, by the formula, the y prime equals to, so u, that is phi prime, plus v, where we have u prime. So what is our u? U is exponential of 2x dot, what is our phi? What is our phi prime? Phi prime is 3x squared plus, so we have v as well. The phi here is x raised to the power 3. Then the u prime is 2 exponential of 2x. So here we can have this as 3x squared exponential 2x plus, so here is 2x raised to the power 3 exponential 2x. Your answer can be like this, or if you like, you can factorize. So factorizing this out, we have exponential 2 here, exponential 2 here. Here is x squared, so we can still take out 1x squared from this. So here I can have this as x squared exponential 2x. So by taking x squared and exponential 2x from here, here we have 3 left plus. So here I've taken out the exponential 2x and the x squared here. So we are going to have 2 and x as the remaining here. So therefore, the y prime for this particular product rule differentiation is given as this: x squared exponential 2x bracket 3 plus exponential of 2x. If that is clear, so let's see another example, which is example number 3. So I want to show you the product rule of the logarithmic function and the quadratic function. So let's see the product of logarithmic and quadratic. So let's say suppose we have question 3. So if y equals to x squared logarithm of x. So remember we are dealing with logarithm of e. So I mean the natural logarithm. So now to do that, so we still apply the same thing. Note that this thing can still be ln. So you can call it ln or you call it log of e. So they are the same. So to do that, so we let this, then we differentiate. We let this, we let this. Suppose this one is u. So if u equals to x squared, right? Then we're going to have v to be equals to the log of x base e. So differentiating this, we have u prime equals to a is 2x. Then differentiating this, we have v prime equals to differentiating log of any number, log of something like this, log of x, we are going to have 1 divided by x. That is standard. So now to obtain the dy dx, which is the derivative, so a is our u from the formula u v prime plus v u prime. So what is our u? U is x squared. Then we have v prime to be equals to 1 divided by x plus, what's our v? V here is the log of x base e multiplied by, then what's our u prime? U prime is 2x. Okay, one we cancel one here, we are going to have x plus, so taking out these 2x, we are taking 2x at the back, so still the same thing. Then we have log of x base e. That is the final answer, or if you like, you can factorize x out from this expression. Taking out x here, so we are going to have something like this, x bracket, so we are going to have 1 remain here plus, so taking out x, we have only 2, then log of x base e. So here is the different example to the product rule of differentiation. So any question that comes from this, I'm believing that you should be able to tackle it with peace based on the different examples I've given above. Alright guys, I'm going to stop here for today and I will see you in the next class. But before I go, let's us try this question. So let's just try it just for us to be well assured that we really understand this very concept. Okay, I'm going to give you this assignment. Yeah, let me call it assignment. Okay, so suppose we are given something like this. So we have to find the dy dx. So to obtain the dy dx of this, suppose we are given y equals to, here is x squared, then we have exponential of 2x cos x. So we are given this particular expression, so I'm going to do it. It's very simple. So what I'm going to do is let this one to be u, let this one to be v, and let this one to be w. I will see the answer in the comment section below. Don't forget to subscribe to my YouTube channel. I will see you in the next class. Bye for now.